SPSS is a tool actually to help the student, especially for the masters and PhD student, to analyze the data. To analyze the data. However, beside the SPSS, another software also conduct the analyze data, but SPSS is more popular in the Malaysia, especially from the student itself. Sometimes SPSS also is popular to the operator in Malaysia to conduct the analysis data and to run the data to check whether the data is valid or not valid. Okay. For today, between 3 hours, actually, this workshop actually I take around 7 or 8 weeks to conduct this workshop. But today we have only 3 hours to conduct all the concept, all the analysis. Okay. However, I suggest you to make sure you more understand about the analysis and SPSS. It's better you further reading about the SPSS and how to analyze the data. And the third one, try using your data, not the dummy data. Okay, because this is very important, especially to make sure you understand how to run the SPSS and analyze your data. Okay. Okay. For today, we have the 6th agenda. The first part is about the basic concept of measurement. The difference about the parametric and non-parametric test, and we are going to understand the view of the SPSS and how you prepare the data and how you insert the data in your SPSS. Secondly, how you save the data and how you check the data is valid or not valid. And number 5 is about we test the data. Okay, the data we test about if your data is fulfilled for the parametric or non-parametric test. Okay. So normally we test for the normality distribution, and secondly we find out if the data have the outliers. So this concept I will discuss in the next chapter about the two of this concept, because normally two of this concept is the examiner will ask you, how do you know about your data? Your data is normally distributed, or do you have any outliers about your data? So based on the SPSS, we can predict whether your data is normally distributed or you have the outliers. And lastly, for the second part, we are discuss about the inferential statistics, especially for the parametric test. So we run 3 types of the inferential statistics, such as t-test, ANOVA, and correlation, because the 3 of these statistics is very popular among the student, especially for the student masters. Student masters. For the PhD student, normally they are using more advanced statistics, especially for the SEM, or sometimes we call the structural equation modeling. Okay. However, before we run the SEM, we should know about the correlation, because correlation is a part of the SEM. Okay. So the basic correlation is very important to understand that your data in SEM is suitable or not to run the SEM. Okay, we go to the basic first. I assume you already understand about the dependent and independent variable. This is a very basic in the research methodology and in your problem statement. Remember, if you check or you discuss about the problem statement, normally your supervisor will ask you which one the independent and which one independent variable. Normally, for the research problem, you should discuss about your dependent variable, not your independent variable, because that dependent variable will be a part of the your problem statement. Why you want to study about the dependent variable? Okay, so what is a dependent variable? Dependent variable is about the variable will be influenced or modified by the another or other variable. For example, is about your achievement. Okay. For example, dependent variable is achievements or outcome, or sometimes it's about the score. Either is a mean score. Normally, if you run the parametric test, that means you are to compare the mean score, not the median score. Median score is referred to the non-parametric test. Okay, the output. So what type of the output is depend to your definition or operational definition. Maybe sometime output you say is about motivation or achievement. Also we call is output. Sometimes output is also referred to the profit. If you're in under business, you know about the profit. Also cost, maybe cost of living, and depend on your research field. Number of unit of sold, opinion, and etc. So dependent variable is depend how you define the dependent variable in your research. Normally, sorry, normally the dependent variable you can find out from your LR or literature review, because the literature review will guide you to show you that the variable is independent or dependent variable. Okay, so that is the dependent variable. The second one is about the independent variable. Okay, the independent variable normally will be influenced to your outcome or your dependent variable. So how you find out the independent variable? This is also from your LR. Okay, when you conduct the LR, either you are using the bibliometric analysis or SLR analysis, you can find out which one your variable is independent. Okay? Or you can find out which one your dependent variable. Okay. So normally for the master student, they found that independent variable is normally to represented from the demographic factor. For example, age, gender, the income, okay, the location, anything else about the demographic factor. Okay? This is for the normally for the student masters. But for the student PhD, sometimes they are using the demographic factor as a dependent. Sometimes independence is also is about the other variable we can measure based on the ratio or interval data. Sometimes. Yeah. For the PhD, another one variable they're using as a mediator variable, or sometimes they call it a moderator variable. That is for the PhD level. Okay? But for the master's level, for our basic SPSS, I just talking about the dependent and independent variable. Okay. Okay. In the SPSS, normally we have this type of the variable. Either you can write up your variable in string, or we call the in the words or numeric number. Either you can use the words or number. And the format your data is only 3. Actually, it's 4. But in the SPSS, the scale is referred to the data from the interval and data from the ratio. And also we have the ordinal and nominal data. Okay. So this is a for example. Uh, this example actually is not refer uh, for this categorical because this is more to the nominal data. Okay. For the skill data, actually you don't need to divide the data. And for example, from here you divide for the four categorical. If you divide already four categorical, that means your data from the interval will be changed to the nominal data. So it's better if you have the data as the respondent based on their data, not you are to categorize the data. You can categorize the data after you get the data from the original respondent. So this is ordinal data. Ordinal data something like Likert scale from 1 to 5 or from 1 to 7. Okay. So when you ordinal data from 1 to 5, the data just show about the ranking or the order ranking. Okay? Not to show about the mean score, the mean score of the data. But after you analyze the data based on the SPSS, so you can get the mean score. That means the mean score is not just ordinal data, but is refer to the interval or ratio data. So the mean score is refer to the interval or ratio data. But if your data is not in the mean score, for example here, the Likert scale, that means your data is still under ordinal data. Okay? This is ranking data. Sometimes I call it the ranking data. Why the ranking data? Because just to show the ranking. We don't know the gap or the range between 1 to 2, 2 or 3, or 3 to 4. We don't know. Yeah. If you want to make sure the range is a similar 1 to 2 or 2 to 3, so you need to change this data to the interval data or ratio data. So because the interval data is have the equal range between the number. For example, the temperature. Okay, so the temperature is more to show about the data. We call interval, or sometimes we call the ratio data, because the temperature is a same measurement between the number. Okay, compare for the Likert scale. Likert scale we don't know the range between 1 to 2 or 2 or to 3. Okay. Okay. Nominal data. So nominal data is referred to categorical data. The number just to show about the difference between the group, not about the ranking or not about the score of the data. Just to show the difference between the group. For example, your gender. Maybe you want to give the number for one for is male or two to the female. So the number is not to show the ranking, just to show the difference between the group. Okay, so that is the nominal data. For example, hair color. Maybe you have the three types of the color. Okay, so maybe number one is the black color. Two maybe it's a yellow color, and that is the brown color. So the number is just to show the difference about the color in the categorical variable. Okay. So what is a statistics? Statistics is about data collection and data analysis. So statistics is about data collection and data analysis. Okay, so how you collect the data? Your data will be collected from the sampling method or the target population. When you are talking about sample, that means you are trying to predict the population parameter from the sample. Okay, so that means what is happening in the sampling is also to represent it to the population. I'll be right here, baby. You know it's sink or swim. Okay, thank you. Okay, so how you select the sample? So how you select the sample? I hope you read about the research method. How you select the method, the sampling, and the size sample. Normally, for the inferential statistic, you have at least 30 sample or 30 respondents, okay, for the parametric test. Below the 30, normally we run the non-parametric test. Okay, normally we run the non-parametric test. Or if your data is not in normally distributed, even though you have the large sample, so you also to run the analysis using the non-parametric test. So make sure your samplings is under probability sampling, not non-probability sampling. So what is the example for the probability sampling? For example, is a random sampling or systematic sampling or strata sampling. So that is about the probability sampling. Okay. Okay. From the data, after you collect the data from the sample or respondent, so you run the data and you run data based on your research objective. Not everything you want to run in your analysis because SPSS, anything you can be run your data. But I suggest you just the run analysis based on your research objective or your hypothesis. Eh? Normally, we have two types data analysis here. First, about the descriptive statistic and statistical. What example for the descriptive statistic is about you just know about the frequency, you just know about the percentage, or maybe you want to show about the mean score or median score, including the standard deviation. So that is about the descriptive statistics and statistical. The second one is about the graphic. So you can represent your data based on the graphic. For example, histogram or pie chart or the line chart. It depends to you which one the best graphic to show about your data. For the line chart is better if you run for the longitudinal data. You look for the trend, the data. And your data will be increase or decrease. So you can see the trend. But if you run the histogram or pie chart, that means you just only to compare the categorical of the data. Okay. And lastly, about the statistical inference. Yeah, statistical inference is very popular among the student. Okay. Why? Because the statistical inference is more easy to analyze. Actually, non-pragmatic is more easy. Actually. It's okay, never mind. Okay. Never mind about your why you choose the statistical inference. Okay. So we will conduct about the statistical inference today. Okay. So before we run the either you're using the statistical or not, um, you first you must understand about two type univariate technique analysis in your data. First, we call parametric test. Okay, the parametric test because you're using the interval and ratio data. On the left of the figure, this one, to show about the parametric test. And the right figure is about the non-parametric test. Okay. Why? Because the parametric test only using the interval or ratio data. Manual for the nominal or ordinal data will be run the non-parametric test. Okay. So today we are talking about the data, interval, and ratio data. So we run the t-test, one way another, and also correlation. Okay, because it's about the independent variable. Okay. So this is basic for the difference between parametric and non-parametric. Okay. First, about the distribution of the sampling. For the parametric, your data will be normal, but non-parametric, either is normal or not normal is okay, no problem. For the variance is referred to the data to compare between the group. So the parametric test, your data must be homogeneous, but non-parametric is okay, anything. Typical data, I already mentioned that. Parametric only except for the ratio or interval. Manual the non-parametric, ordinal or nominal. Data set of relationship should be independent among them, but non-parametric is independent or dependent. Okay. To test your hypothesis, for the parametric you using the mean score, but for the non-parametric using the median score. Okay, median score. And the benefits of the parametric and non-parametrics is there. Parametrics can draw more conclusion. That means you can predict the population parameters. But non-parametric only for the your sample, not to predict for the population. That is very simplicity, less affected by outliers. Okay. And this is a test for the parametric and non-parametric. For example, for parametric test, we use the sample t-test, bad sample t-test, one-way ANOVA, repeated measure ANOVA, Pearson correlation. Okay. For non-parametric test, we are using Mann-Whitney U-test for independent sample t-test. Bad sample t-test, we using the Wilcoxon sign rank test. For the comparison more than 3 independent variable, we using the Brusca-Wallace test. 3 or more repeated measure, we call the Friedman test. And if your data is not normally distributed for the correlation, we're using the Spearman correlation. And if your data is more to the nominal or ordinal, to check the correlation, normally we're using the chi-square test. Okay, the chi-square test. Okay, that's it. Basic for the difference between parametric and non-parametric. So make sure if you run the parametric test, you must fulfill the assumed assumption from the parametric test. If your assumption is not fulfilled for the parametric test, that means you need to run the non-parametric test. Okay. Okay. However, either you using the parametric or non-parametric, you still using the hypothesis. Okay, you still to test your hypothesis. Either is significant or not significant. So, don't worry about the hypothesis because the parametric can be test the hypothesis and also the non-parametric also to test your hypothesis. Okay. SPSS is referred to the software to analyze your data, and normally SPSS under IBM. SPSS, based on the history of the SPSS, starting from the SPSS for DOS. So SPSS for DOS, normally you insert the data, and also you must create the formula to run the analysis. But the SPSS for Windows, you don't need the create the formula. You just insert the data and run analysis. So you get the output from the SPSS. SPSS very popular among the student in the Malaysia and also from the lecturer. Why SPSS is more popular? First, it's very easy to summarize the data. You can get the mean score, standard deviation, percentiles, mood, and median, and etc. Secondly, you can present your data using table and graph. Okay, what I mentioned before this, you can use the pie chart, histogram, and also a slide chart or plots. And the third one, you can test the hypothesis using t-test or ANOVA to test either any significant difference between group. So you're using t-test or ANOVA. Number 4 is about to test the relationship among the variable. Okay? That means independent variable and dependent variable. Any relationship between two these variable. And more complex data, we are using structural equation modeling, forecasting, and clustering, and etc. SPSS also can run the SEM, but you need another software we call MOS. Okay? MOS is under SPSS. Okay? The other one, beside the MOS, we can run the Smart PLS. Also, is about SEM. Okay? So another statistical software is similar with the SPSS, like as SAS, Systat, Minitab, S+, or R, and many others. So there is the same analysis, but it's more easy to run the SPSS. For the economic student, normally they use eViews software. Okay? Because the eViews is more powerful for the dummy data. So for the economy student, it's better you using the eViews compared to SPSS. But sometimes I also find out that the student economy also using the SPSS to run the data. Okay, okay. Basic steps. Basic step in data analysis. Before you run the analysis the data, first, your data can be read by the SPSS. Normally, the data either in the numeric or words can be retrieved for the SPSS. If you don't have the data, but you have the respondent, SPSS will be set the respondent is a missing data. It's a missing data. Okay? It's a normal in your questionnaire. Sometimes the respondent not answer your question, especially from to the demographic factor. Sometimes the respondent not to tick or insert the data, especially for the gender, the income, the age. So if the data is not there, SPSS will be called this is a missing data. Okay, the missing data. Okay. Okay. The second one, you prepare data. So before you insert data, make sure your data is fulfill insert in your questionnaire. Sometimes the data is not fulfilled the questionnaire, That means this respondent you will be removed from your data analysis. But remember, um, if you are sampling, for example, based on the Critchy and Morgan, normally the student using the Critchy and Morgan, they assume you have the 200 respondent. So this is Critchy and Morgan to get a 200 respondent. If the respondent not to answer your question, that means you are not fulfill the 200 respondent. So you need another respondent to achieve the 200. This is very important because sometimes if your data respondent is not enough based on the what the scholar suggests, that means you cannot run the parametric test. Okay? You just run the non-parametric test. So you need to clean your data and apply any needed transformation, especially from the missing data. The missing data. But for me, the missing data for the demographic data is okay. It's okay. But for the instrument in your questionnaire should be answered by the respondent. Respondent. This is very important because you try to analyze the dependent or independent data. And then number 3 is about the procedure you analyze. So once again, I remind you that if you run the t-test, that you just select the procedure of the t-test only, not all the t-tests you want to run. Okay? Only a certain particular to using the procedure. And then if you run the table or the figure or the chart, make sure your data fulfill for a certain chart or figure. Okay? Sometimes we need the figure to show is more powerful to understand. Compare you are just explain in your write-up. Number 4 is about the variable. How many variable you are select in your research study. If you have the 3 variable, that means you need 3 variable. Not all the variable you want to analyze. Okay. However, normally for the student PhD, because they must fulfill graduation assumption, they need to write up 2 articles. So 2 articles. That means he can analyze the another variable to build the 2 type of the article. Okay. For the student masters, currently the SPSS not compulsory for the student masters to produce the article, only for the PhD or doctor education. Okay. And run the procedure, the analysis, and make sure you understand how to interpret from the output SPSS. Normally, the SPSS just produce the output. How you interpret based on your reading and based on your hypothesis. Okay? So that is very important to understand that you will know about the how you interpret the data. Sometimes students are not understand how to interpret data. Okay, okay. I suggest. Okay, I suggest if you get the data in terms of percentage, okay, the percentage, you should be starting from the higher of the percentages, and then the second and the third one, and then the third one you more discuss why is the lower compared to the another? Because sometimes the lower percentage will be one of the indicator for your problem statements. Okay, so that is how you interpret your data. So how the SPSS can get the data? Okay, normally we have data from the spreadsheet, or sometimes we call from the what we call is Excel file database, from database now. So database, and normally I already using the database. The database normally, if you are run from, for example, is Monkey Survey. Monkey Survey is one of the database. So the database will be converted to the spreadsheet or to the Excel, and then you can download that Excel file and you can run that SPSS. And the third one is about the text data. So the text data, these are very simple data. Only you just key in the data or numbering data. So for the SPSS for those, they're using this one, the text data. So the text data should be inserted in the DOS data, compare the split data. So we using the split data to run that data. Okay? And then you open the SPSS. From the SPSS, you retrieve this data. Okay, retrieve data. Sometimes the SPSS cannot understand or try to retrieve the data. Okay, to retrieve the data. Okay. However, it depends to you what type your data. Okay, what type of your data. Okay, if you run the SPSS, you have two windows. First, we call the view, the data view, and second one is variable view. So data view is about the preset of the cases row and variable. So the data view is you insert your data. Okay. Sometimes you can insert the data directly to the SPSS. Sometimes you can retrieve the data from your spreadsheet or Excel data or the text data. Okay. So the variable view is about your data is to show how you create the data, okay, in your SPSS. Okay. Here I give you the example. In the example, this is a data, your data. So the data is you insert the data here. Actually, okay. You show this one, the dot one. The dot one is referred to the missing data. The missing data. Compare the zero here. So what this means is zero. Is in the species, zero is something else. You can calculate by the species. So make sure is the difference between the zero and the dot. Dot is, that means is missing data. That means the respondent is not insert their data. For example, here the H. Okay? Respondent number 2 not insert the H here. So the data will be missing data. Okay, the missing data. How about this one? Number 5. Respondent number 5. They have data there. And this data, you should be checked again in your questionnaire. Either is 0.00 or is a missing data. Okay, or the missing data. So you need to check again. Okay. So this is what we call the data view, to insert your data and you can see all the data in the same time. Okay. The second one we call the variable view. You can click variable view and data view. Okay. This is data view, variable view. Okay. So the variable view is about you create the name of the variable. For example, here name here study ID. ID is referred to the number of the respondent. Variable number 2 is date of enroll. And variable number 3 is about date of birth, age, ethnicity, race, sex, and so on. So to make sure this one, we call is a variable name in SPSS. Okay, variable name is SPSS. But if you're looking for the label here, the label is variable name in your questionnaire. Your questionnaire. Okay, so that means you have the two variable name from the SPSS and the another one is from the questionnaire. Okay, so you need to this one, but normally the researcher the label one they want to insert, but they're using the value here. Okay, the value here to insert the data. Okay, to insert the data. Okay. How to insert? We will conduct this one workshop to open the SPSS and to run the data. Okay. So this is the description in the SPSS attribute, name, the name of data, type, what type of your data, okay, it's numeric or string or what, with the digital, okay, and also, okay. Okay, variable name is usually the name is must be unique and only the researcher understand the name, not the other respondent, only the researcher. So how long the length of the character is only 65, the maximum. The name can be contain a letters, numbers, or special character. Okay. Name must start with a letter or the symbol here. Okay, it depend to you. The data type, we have two type of the data type. Normally, we are using the numeric and string. So numeric is about the number. For example, here currency, comma, scientific notation, and etc. But normally we using the number. The second one is string. String is about the something any characters, but normally we using words. For example, male and female. Okay, male and female. Variable width. So how long the width is depend to you. More shorter is more better because you can see the data. Okay, decimal. Okay, sometimes your data need decimal. For example, for the currency symbol or for the money or for the dollar. So you need the decimal. But sometimes your data is not using the decimal. Okay? Not using the decimal. So it depends to you either you want to use the decimal or not decimal. But in the output process, you need the decimal because you want to check the mean score. Because sometimes the mean score we have the two number decimal. So you need the decimal and the score. That either the mean score, standard deviation, or the median. So we need a decimal. Okay. Variable label. So variable label is a variable name beside the name of the variable in the SPSS. Normally, the variable label is referred to your questionnaire variable. And the questionnaire variable. Value label. So value label, if you have the data in terms of ordinal data or nominal data. So you need the value label. How to do the variable data? Okay, we will run the SPSS shortly. For example, here, value label 1 and 2. So if you click 1, the 1 is referred to the male and 2 is referred to the female. Or 1 If you are example for the code for the location, okay? One is referred to the urban, second maybe is about the rural area. So you have two categorical. So we need the value labels in terms to understand, okay, why these two of the value label is important. Sometimes we need this valuable label to run your analysis, especially for to run the t-test and ANOVA. So we need the value labels, to show the difference among the groups. Okay? And missing value. Okay? The missing value, normally we are talking about the uh, uh, either the respondent is not insert the data or you are not insert the data to the SPSS. Sometimes researcher miss the data. So if you have the missing data, after you run the data, you show that the missing data, you can check again your questionnaire. Either it's really the respondent is not insert the data or you as a researcher not insert the data in the SPSS. So you check again the questionnaire. Okay? Column one is okay. More shorter is more better. Okay, the alignment of the value in the data. Normally, the alignment is the right side. Okay? But sometimes some researcher want to the center alignment. It's okay. It's okay, but it's me. It's better to show the right alignment. Okay? The right alignment. Okay, in the SPSS, once again, I to show you about the level of measurement in the SPSS. We have three only: nominal, ordinal, and scale. Okay, scale is referred to the interval and ratio data. When the ordinal only to just ranking, and nominal data is about the categorical. Okay, the category. For example, male and female. And the other one is about the rule. It's depend to you either the rule of the variable is an input or what. And maybe it's a target also. Or both or none. It depend to you define the role of the variable. Okay. I will teach you how you compute, how you count, and how you record. But the most popular among the students is about how you compute and how you record the data. The count is not quite easy for the student, but it's more important is for the compute and record. Because the compute actually is to sum the item, a multiple item to one another variable. Record that means you record the item from the positive to the negative. Or you create another variable. So you will using also record data. Okay. So the most popular to run the procedure in SPSS is about your analyze from the menu. Okay, procedure are grouping according to type. For example, report, descriptive, statistic, complement, table, general linear model, and so on. Okay. Okay. Can you open? I assume you have the SPSS in your laptop or your PC because we try to practice to run the SPSS. Okay? If you don't have the SPSS, I don't know how to help you, but you just looking for the how to run the analysis of the data. Okay. Okay. First, we open the SPSS. For example, this is SPSS. Okay, this is SPSS actually is version 26. Okay. Currently, we have the version 29. But I still using that 26 because it's a very easy me to understand. because there is no so many pages, but it's a certain thing is more important to my analysis. Okay? Because the output from the SPSS is the same. Either are you using version 26 or 29. But here I'm using the SPSS 26. Okay. How you install your SPSS? This is my suggestion, not compulsory. Huh? You can ask the from the VHL computer to install your SPSS, or you can buy from the online. Okay, from the online in your website. Okay, you can buy. Okay, so my vision is 26 only. Okay, the current is the 29. Okay, okay. So what I mentioned before this, we have the data view here and variable view here. So the data view is about you insert the data here. Okay, for example, here you insert the data. The variable view is about you create the data and you maybe sometimes you add something characteristic in your data. For example, name, type, weight, decimal. I already mentioned in my PowerPoint. It's about the label, values, missing, column align, measure, and the roles. Okay, and the role. Okay, can you open my example data here? Contoh 1. This is the data. Okay, before we insert the data, we go to the variable view first. Okay, the variable view to create the data. Okay, look for the name of the data here. ID, gender, age, IB, and DB. IB is referred to independent variable. DB is referred to dependent variable. Okay, we have that type here. ID is numeric. Gender is string. Why string? We go to the data view. See the female, 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 male, 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 female, female. Age is a numeric. Independent variable string and dependent variable numeric. You go to here. Okay. Sometimes it's represented to this symbol. If the symbol is like a rural, that means it's a numeric. If you see the something three of the color here, is referred to the string or nominal data. Okay, these are nominal data. Okay, so based on the SPSS here, so this is the file. Okay, file is contoh1.sab. So ID is referred to IT respondent. Gender, one female to female. CBT, cognitive behavioral therapy, and electric conservative. Depending variable is a life certification rating. So these are the name of the variable in your questionnaire. So for example, this one example, we will go back this one after we try to how you insert the data. Okay? So this is the exercise, how you retrieve the data. Okay, can you go the data job survey, data text? Okay, you go to the file, open data here. Okay, this one. Okay, data job survey. Okay, data job survey. Okay, and then you open. Okay, and then you click continue, 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 and done. So this is the data. Okay, this is the job survey data. Okay, it's already this data. However, in the variable view, it's still not you insert or you key in the data. You have the original data. So variable 1, variable 2 until variable 24. Okay, variable 24. So how you change this variable and how you change the variable and value here. Okay. For example here, I have the code here for the variable name and SPSS name based on the variable. Okay, the variable number 1, you change to the ID. Change that to ID. And value label D. Okay. Can you follow this one? Number 2 is about the ethnic group. You refer to ethnic. Variable 3, gender. So say gender. Number 4 is age. 5 years. Number 6 is commit. Number 7, satisfied. Satisfied. 33. And satisfied. After that, autumn. Autumn 2. Autumn 3. Autumn. That routine 1. Routine 2. Four. Okay. And then another one, the variable is at 10. Skill. Growth. One. Okay, up to you how you run the data. Okay. This is for example. I think it's not. Oh, this one is income. Income is not there. Okay, income. The gender is income. Okay. Get this ID. And then in the value, you need to insert. For example, here, ethnic group. Okay, here, ethnic group. Okay. Okay. Based on this, your characteristic. For one is white European. Okay, first how to insert this one. Okay. Okay, is here value one is referred to the white or European. Okay. And at second is referred to Asian. At three referred to West Indian. Four referred to African. And five referred to other. And also you get here. For the male and female, this one also is the same. And the rest. We just follow this one. Okay. I already insert is here. For example. Okay, already here. So this is the original data. So run your data. So you need to understand the categorical data in your SPSS. And then your data is nominal, ordinal, interval, or dichotomous. Normally we have three types of data in SPSS: nominal, ordinal, and scale. Okay, what next? After you insert the data, after you name the data in your SPSS, the next step is you save the data. Save data. How you save data? Okay, for me, I save the data as a job survey 13 September. Why 13 September? Because this is the first data you insert in your SPSS. Okay. After that, if you need the data, maybe the next week. So you insert the data again and the original data, and then name it the second data maybe on the 14 September. So you know the date of your insert the data, when and how many sample you already have the data. Okay. Okay. Suppose you have already the enough data. For example, you have the 200 sample, okay, from your data. Okay. This here, how many data? We have 69 data on it. Okay. Suppose you have the data, it's already 200, and then you name the data is a original data. Maybe for this one, job survey original data. Okay. Why I ask you the name of data is original? Because this is your original data. Sometime will be your delete or remove your sample or remove your data. So you still need have the original data. Okay. After you remove or rename the variable name, you need to save a new data.
Okay, send you everyone take picture
From
of you.
the original data to the new data. Because this is very important to understand that how many times you will be change your data, remove your data, add your data, and so on. So you know. Okay. So this is original data. For example, here job survey is here. Okay, job survey is here. Okay. Okay. What next? Sometimes you need to we don't know the data, how many gender, how many male and female. For example, here. Okay. For example, here you want to select gender is referred to one. Okay. Refer to one. Okay. This one. Okay. A certain cases. Okay. So how to do it? Okay. You go back to data, new data, this data. Okay, here. Okay. You want to select a gender here. Okay. So how you select the data? You go to the data. Okay. Remember this data. Go to scroll down to below. Before which case is select cases. Okay, you select the cases. Okay. And then you select the gender. Okay. After select the gender, in the select windows here, you select the if condition is satisfied. If condition is satisfied, and click if. So the another window is here. So which one? You click gender and bring to this here and click equal to 1. And continue. And okay. So this here how the output SPSS is already here. Compute filter gender 1 is not here. So you go back to our data and we look for the data. Yeah. So the SPSS will be unselect for the data number 2 or the number 2 in the gender. Only number 1. Okay. Okay, and only number 1. Okay. So can we check either is true or not? We go to analyze. Click to analyze. Click descriptive and frequency. Okay, once again, analyze, go to descriptive and frequency. Click to gender and bring to the variable. And click OK. Okay, see this one, the output here. There is no missing value, but from this data we found out the male is 30 respondent. So they only select 38 respondent. So that is mean it's about the you select the cases. Okay. Okay, go back to our data. So how you remove this one? Okay, this one. So go back to the data and scroll down to the select cases. Select cases and go to the receipt here. And then okay. So yes, here there is no certain cases. Okay. Okay. The second one. We have how many respondents here? We have the 1670. 70. Okay. Suppose you want to select the random sampling from this your sample. Suppose you need 10. Only 10 respondents from the 70. So let the SPSS select random the sampling. So how? Go back to the analysis, select cases. Okay. You go to the random sample of casing. I think. Okay. So sample, click sample. So click the exactly. For example, you want to 10 from 70. Then click. Okay, what happened? Okay. So the SPSS was help you to select the 10 respondent from the 70. So the respondent is number 1, number 9, 10, 7, and also. Okay, number 43 and okay, 90. So that is your respondent. So that is the how the selecting case. Okay, the selecting case around the respondent. So this is another how to run the uh, basic analysis data. Yeah? Equal to, not equal, less than, and so on. So you can combine the data. Combine the data, or can you remove the data? Okay. Record. Okay. Before you go to report, I will talking record this one after we go to the reliability analysis. Okay. After we go to the reliability analysis. Okay, this one. Okay, the most important is about the compute the new variable. Or sometimes we call the what we call is create the new variables. Okay, I show you how you create the new variable here. We go to the SPSS again. For example here, we have the autonomy variable here. Okay, so we need to compute the new variable to represented from the represented from the 4 item to show this is a autonomy. Okay. How you compute? Okay, you go to the transform, compute variable. So the compute variable actually is you create the new variable or you transform the new variable. So you compute variable. So what is the new variable? So let's say you want to create the new variable with the name autonomy. Okay? Autonomy. So the autonomy variable is represented with the four this item. Atom 1, atom 2, atom 3, and atom 4. So how you combine three of this item? Okay. First, you go to the function group here. Okay. Function group here and scroll down until you see the statistical here. And click statistical here. And go to the function and special variable and go to here mean. Mean, not MIN. MIN is referred to minimum. So here is mean, MEN, the average. Okay. So double click here. And the mean here is appear in the numeric expression windows. Okay. Okay. After mean words here is referred to the question mark is here. So question mark actually is referred to the item. To the item. So we need to delete this question mark. Okay. So we need first atom 1. Double click atom 1. After 1, you need to click the comma and atom 2, comma again, atom 3, comma again, and atom 4. So we have the item here, we compute here to represent it to the autonomy variable. It's a new variable. So after that, we click OK. Okay. So it's already there. Okay. We go to our data to see either the new variable is there or not there. So you click this data on the right one. So we have the new variable here. We call the autonomy. Okay. Do you see this here, the autonomy numbers? We have the decimal, 2 number decimal here. So you don't need to change here your decimal to 0. Because this is your data is already changed from the ordinal data to the interval data. So this is the interval data because we have the same range between the number. Okay, so we have here. And we have here. Okay. So the most important, you know about your data. Okay. If you don't know about your data, so you cannot simply compute the new variable. Okay. This is same for the routine variable or item. Can you try again to compute the new variable? So autonomy, you change to the routine. And this one, you just change the item, go to routine 1, comma, routine 2, comma, routine 3, comma, routine 4. And click OK. So we got another variable we call routine. Okay, you can see all this one. Before we run the parametric test assumption. One another criteria in the parametric test about your validity and your reliability. Okay, your validity and reliability. First, about the validity. Validity to assume that your instrument to measure what you want to measure the construct. That's validity. Reliability is how consistent your item measure the construct based on the culture, based on the time period, and based on the gender, or whatever. Hmm? Especially, normally we are talking about how consistent the item based on the different culture and different location. For here, example here, we try to run the reliability. We have the three variable here. It's very important. We call satis, autonomy, and routine. So can we check the reliability of the three of the variable here? Okay, first we go to analyze. Click to the scale. Okay. From the scale, you click the reliability analysis. Okay. And go to here, every of variable. Okay, first about statistics. Okay, you go to statistics. Okay, I repeat, click statistics. Click only one here. Scale if item deleted. Scale if item deleted. So click continue and okay. Okay. You run again for the routine, for the autonomy. You just change this one and go back to the other window. So go to autonomy, bring again to the item and click OK. And the third one is a routine. Routine. Okay. We go for the routine first. Okay. So what is the guideline? The guideline to show that your item is reliable based on the reliability alpha chroma. Okay. First, we go to here for the item for the routine. We found is 0.9. Okay. Normally in the social science, at least 0.7. Okay. At least 0.7 is acceptable to show that your item is reliable. So from here we have the 0.9. That means it's about above 0.7. And look for the corrected item correlation. Okay. I corrected item correlation normally to show that the item is valid or not valid to the construct. So how to know that the item is valid or not valid? We refer to the value of the corrected item correlation. Based on the scholar, if you have the 0.3 and above, that means your item is valid for the construct. So from here, we found that there is more than 0.3. So that means the item, all the four items is valid for the construct. So the construct is referred to the routine. How about the autonomy? So autonomy, we found that also the corrected item total correlation is more than 0.3. More than 0.3. That means all the item also is valid for the construct for the autonomy. How about the status? Status. So also is valid, even though the item, one of the item here is nearly to 0.3. Okay, nearly to 0.3. So this is okay. So okay. So that means all the item and all the constructs is valid and reliable. Valid and reliable. Okay. So how about if we are talking to record the status 1 and status 1, status 2 and status 3? Okay. We record. Okay. Okay. Can we record these two items? For example, here, status 2 and status 3. So how you record this item from the uh, higher to lower and lower to the higher? So you go to the transform, record into different variable, not to record into the same variable. Yeah? Let the original item is there. Okay. Let the original item is there. Okay. Don't change the original item in your file. Okay. So you go to record into different variable. For example, here is status 2. You click status 2. Okay. The numeric variable is status 2. You change the new output variable. So, for example, here you change from the status 2 to R status 2. R is referred to record. Okay. Record. So click the change. And now the status 2 is changed to the R status 2. And go to the all and new value is here. Okay. Once again, click all and new values here. And you change from the higher value to the lower value. For example, 5, the new variable is 1. Okay. 4, change to 2. Okay. 3 equal is 3 also. 4 equal to 2. 2 equal to 4 and 1 equal to 5. For example here. Okay, for example here, from the higher you go to the lower value. So continue. And okay. Okay. And once again for the satisfy. Satisfy, you transform again to the another variable. Okay, satisfy. We change to R satisfy. Change. All value is already there. So click OK. And then we run again the reliability analysis. Any change to the analyze skill, reliability. So you click one here entry here and set this. There is also. See, when you are recode the item, we found the alpha chroma is negative. That means the item is not suitable to represent the satis. So the corrected item coloration is also is negative, and alpha chroma also negative. That means your item here is not what we call represented or not to measure the construct is satis. So totally all the item is not construct the variable. Okay, so we need to delete here. Okay, next. Okay, data preparation is about you check the data in terms about your maybe you're missing observation or you have the outliers. So outliers is about the data is more extreme. Only one or three of the respondent give the data is more extreme is or is not in the other cluster. So we call these outliers. Okay. Secondly, about your distribution of the respondent data. We need your data is normal to run your parametric test. Okay, your parametric test. Okay, sometime if your data is not normal, you can normalize the data. If you still run the parametric test. So how you normalize the data? First, maybe you add more your respondent. Secondly, you check again about your data. Either you have the outliers or you have the respondent is not answer your data. That's the third one is about linearity. Linearity is about if you run the correlation, you need your data is linear straight line. If your data is not straight line, that means you cannot run the correlation. And number three is about the homozygosity. The homozygosity is about the pattern of your data. Okay, the pattern of your data to show that you don't have the data is something funny or extreme. So we need your data is you can predict the data is very good or not good. But for this workshop, I just only to show about your outliers and your normality distribution. Okay. So how you test your normality distribution? Normally, we have two types of the normality distribution. First, based on the graphically. Normally, the student master using the histogram or box plot. Sometimes they're using the normal probability plot or they call it a PP plot. And the trending normal plot also is to show the normality test. They're using or sometimes we call is a DD plot. So one PP plot and other one is DD plot. Today we using the box plot only. Okay. For the statistical, yes, we using this statistical method. First, we go to the Komlov-Smirnov and Shapiro wave. And second one is skewness and kurtosis. Okay. Normally, student will use the skewness and kurtosis. I don't know why. Maybe it's more easy to interpret or it's easy to find out. Okay. It's easy to find out. Compare the Komlov-Smirnov and Shapiro wave. However, we try to run these two types of statistics to show that your data actually is normally distributed or not. Okay. For the skewness and kurtosis, Normally, we using the index is between one and negative one. If you get your index number is more than one or negative one, that means you have problem about your normality distribution. However, some researcher, some scholars about the statistic to suggest that plus minus around 2 or negative 2, between 2 or negative 2 is okay for the social science. To show that your data is normally distributed. So we try to 1 and negative 1. If not, we go to the second option. Either you want to use the 1 or you want to choose 2 or 1. But normally I show the student you're using the index between 1 to negative 1 to show that they have the normality distribute based on the skewness and kurtosis. So how you check your skewness and kurtosis will be run through the SPSS. Okay? So outliers. Outliers is data is more than three times from the standard deviation away from the mean. If it's more than 3, that means you have the outliers. Sometimes they're using the Mahalanobis distance. Okay? You see here, Mahalanobis distance to show if your data is outliers. But for this time, we just looking for the box plot to show if you have data, have the problem. Okay, problem. Okay. This is for example for the box plot. Okay, this is an example for the box plot. How do you know the data is outliers? Okay, you look this one. The largest observation and the small adjustment. If you have the data is outside from this line, that means you have the outliers. Okay? You have the outliers. For example, here, this one. Okay, you show this one. So outside, far from this line, that means you have the outliers. Okay, can we go to our data? Can you check our data for the income? So go to graphic. Go to graphic. Click legacy dialogs and click box plot. Okay. Simple and summarize of the separate variable. Okay. Simple and summarize of the separate variables. So you define. Go to where's the income here. Click OK. So this is the income. So from the box plot, we found that the 2 respondents here. The respondent here is show that is outliers. So what is your decision making? If you have these outliers, first you must think about your respondent. Is enough or not enough, or you have more than from the exactly number of your respondent. For example, from the Critic Morgan, you need at least 200 respondents, and your field study is you have the 240. That means it's no problem. You delete or remove these 2 respondents. So who is the respondent? Is respondent ID number 21 and 20 and 12. Is true or not? Why? It's a 0 here. There is no income. So can you check this one? Yeah, it's respondent number 12. and respondent number 21 is 0 here. Okay, so it's depend to you. Secondly, we check again another variable. Normally, ladies and gentlemen, normally if you want to check your data is normal, it's not normal, is only for the construct variable, not for the demographic variable. Yeah? Only the construct variable. For example, here maybe income is your construct. That is your output or your dependent variable. Okay, maybe I don't know. Depend on your attribute. So try another variable. Another variable. So income we already done, and then go to the autonomy and routine. Okay, autonomy and routine. Okay, look for the autonomy and routine. Any outliers there? There is no outliers. So that means your data here for the routine is autonomy is a normally distributed. Okay, this is based on the graphic. How based on the statistical? How about from the statistical? This is for the what we call from the graphic. Okay, how about from the statistical? Okay, this is the outliers from graphical. For the Komlok Samarnov, we also to using the significant value. The significant value. For example here. Okay. If you have the not significant for your data, here it's not significant, that means your data is normally distributed. If your data is significant here, that means your data is not normally distributed. Okay, so we go to our data, check the data again. Okay, the graphic is okay, but how by statistic? Okay, we go to the analyze, click to the descriptive statistics, and click explore. Okay. Go to autonomy and routine again. Bring to the dependent list. Bring to a dependent list. Click statistics. We have as a estimate outliers better. It's okay, no problem. We continue. About the plots. Okay, the plots here, you uncheck the stem and leaf. And the box plot, no need the box plot because we already mentioned that the box plot. You go to the none, but click the normality plot with test. And continue and click OK. So this is the descriptives. We have the statistic here, the mean score here, the standard deviation here, and look for the skewness and kurtosis. This is the number. Okay. I mentioned before this about the value or the index of the skewness or kurtosis is about 1 or -1. But we have here the number, but it's actually is not exactly what is there. Actually, we need to convert this value after you divide with the standard error. So we need another calculation to show that your data is normally this way. So can you open the Excel? So we have the Excel here. Okay. I already mentioned the skewness, standard deviation, kurtosis division. For example, here for the autonomy, The economy skewness we are about is a negative 0. Negative 109. Standard error 0.287. So to get the skewness here is what you to need is skewness divide the standard error. So the formula is here. Skewness divide the error. So we have negative 0.3. So okay, skewness is okay because it's the below negative 1. Okay, it's below negative 1. Okay. How about the kurtosis? So kurtosis is negative, negative 1.151 and standard error is 0.566. So we need here to check again. Divide. So it's true or not? Yeah, kurtosis we have the negative 2.0. Based on what we have mentioned that our kurtosis is not normally distributed. Should be skewness and kurtosis are normally distributed. Okay. Okay. For the autonomy. How about the routine? So routine here skewness and negative 1.418. And the standard error 0.287. Okay. For the routine, negative 0.898. That means all the routine and autonomy is not distributed normally. Okay, based on the skewness hypothesis. And if you go to the Komlov-Semarnov test, we also found that all the variable is significant. Right? All the variable is significant. That mean two of these variable is not normally distributed. So you go to the QQ plot. Okay, I mentioned before this. The trend normality plot is a QQ plot. We found that some of the score is not straightly for the red line. And this here we have the pattern here. Okay, from the higher to lower, yeah, should be the QQ plot is not have the pattern like this one. Okay, for the routine also maybe here is outliers, and also for the pattern of the QQ plot we have the pattern here. Okay, so that means two of these variable is not normally distributed. So what to do? What to do if you have the not significant? That means you need to run non-parametric test. Okay, non-parametric test. That's why we need the non-parametric test to run your analysis data. Okay. Okay. Sometimes the examiner or the supervisor will ask you, if your data is not normally distributed, so what you can do? You run the non-parametric test. So because the non-parametric test also you can test your hypothesis. You can test your hypothesis. Okay, that's it. How you run your data to check your data, any outliers, or you have the data is normally distributed, or if you have data is quite enough to run the parametric test. Okay, parametric test. So you go back to our second part, and now we go to run the SPSS or the inferential statistic. First, t-test. So what is the t-test? T-test is about to determine if two sets of data are significantly different from each other. At least two sets of data or two sets of group. Either any difference or not different based on the significant level. Okay. Secondly, about to determine either the difference between sample and population. That means from the sample is different or not different from the population. Okay, I will be show this one, how to run this one. And thirdly, is about the t-statistic type inferential statistic used to define if there is any deep significant difference between the means. Okay, the means, not the median, the means of two groups which may be related in a certain features. So we want to try to check any significant difference or not. So that means we need to the hypothesis null. Okay, I hope you already understand about the hypothesis null and hypothesis alternative. Okay? So normally for the social science, the minimum value for the significant level is 0.05. 0.05. Sometimes 0.01. But I suggest you using the 0.05. Only 5% is an error in our data, in our sample. Okay, only 9%, but the 95% is a true, not a error. Okay, we have three types of the t-test. One we call the sample t-test, second one independent sample t-test, and the third one is sample t-test. Okay, one sample t-test, normally you using to compare our mean sample to compare the population mean. For example, when we are teach a subject like math in our school, the student in our school is a sample. For example, we have 3.5, and then the mean of the math based on the national examination is 4.3. So we want to compare between our mean sample to the population mean. Any difference or not different? Or which one more higher or more better? Our sample or the population sample? So that is what we call the one sample t-test. Number two, about independent sample t-test. So independent sample t-test, that means you want to test two group any difference based on the dependent variable. For example, you want to compare the achievement between male and female. So which one is more better, male or female? Or if another one is more better, any difference between them, okay? Between female or female. So we call it a independent sample test. Pet sample test, we test two, what we call, we test the sample in the same sample with the two type of the instrument. or testing. For example, we have the testing number 1 and testing number 2. We want to compare this testing. Any difference between two testing, not to compare the group, but we compare the testing. Okay? So we call that is a PET sample t-test. Normally, PET sample t-test we run for the experimental studies. Experimental studies, that means the group will be tested before the experiment and after the experiment. So we want to show any difference. It depends. The difference is influenced by the experiment or based on the sample. So we call that is a sample t-test. So assumption for dependent variable, not independent variable. For the dependent variable, we need your data interval or ratio level. Okay. Secondly, the data should be normally distributed all the groups. What is the minimum group? Each group, if you want to compare. For the classical theory, at least 15 group, 15 respondent per group. So if you have two groups, that means if you join the two group is 30. That means the minimum is 30. But lately, I found that for the comparison group, at least 20 respondent, not more about the 15. So for your study, I hope you have at least 20 respondents per a group. Okay. So the rest is about the p-value. It's about either you want to reject or fail your hypothesis. Okay, we go to the one sample t-test. Okay. One sample t-test is complement with a non-population mean. As I mentioned before this is your sample. These are your population. So you know about the mean population, but you don't know about the mean sample. So you want to test either mean your sample is different with your population sample. So can you go to the file one sample t-test? Okay, I have each of the how many? 22. Actually, it's not enough. It's not enough, but we assume this data is quite enough to run the one sample t-test. Okay, how to run one sample t-test? Or click to the analyze. Okay, analyze. Go to compare means. Compare means, yeah? And click one sample t-test. So what dependent variable are you want to test? With add. Click with add and bring to the test variable. Okay, the test variable. So what is the value you want to test? Okay. Based on the population mean score, we found the mean score is 10.5. The mean score in the population is 10.5. So any option you want to take? No need. And click OK. So what is the result? Result is there. Okay. This is the result. Okay. We have the standard deviation and also standard error mean. Okay. Look the standard error mean. So we have the 22 respondent and mean score for our sample is 13.86. So you want to compare between our mean sample with the population mean. So in our sample mean, we have the 13.16 and the population mean is only 10.5. Any different? Yes. For the roughly we found is different, and our sample is more better from the population. So to check either any difference between to this mean, you go to this here. The T value is 5.74 and degree of freedom is 21, and this is the significant to tell. The significant to tell to show that 0.0001 actually, actually 1, not 0. Actually is 0.001. That means it's a significant. Okay, significant. So what is our hypothesis? Hypothesis null to show there is no difference between the population mean and sample mean. We are reject the hypothesis null. Okay, because this is a difference between mean sample and mean population. Okay. So that means we call is a one sample t-test. Okay, one sample t-test. So here, and now we go to the second t-test. We call PET sample t-test, or sometimes the researcher using the test called dependent sample test. Okay. Sometimes the examiner try to test your knowledge. Are you understand between PET sample t-test or dependent sample t-test? If you say there is difference between PET sample t-test and dependent sample t-test, that means you don't know about the PET sample test. Okay. So what is the PET sample t-test? I was give you an example is from the experimental studies. You have the same sample, but you test twice, pre and post, and you want to see the difference between post and pre. If any difference among them, that's when you have the difference sample test. Okay. So you go back to our data. With our data. Okay. Go to analyze. Complements. Look for the PET sample t-test. Okay. PET sample t-test. Not this one. Where's my data? This one. Analyze. Complement to PET sample t-test. Okay. Without, first you go to without and with add. Click OK. Okay. This is the result. From the PET sample t-test, we found that the mean score for the without is 8.5. Meanwhile, for the with add is 13.6 at 6. So the same sample. So the correlation is 0.5. Please ignore this one because we are still not learn about the correlation. Okay. We go for here. The statistic. Any different? Yes, different is 5.364 with the standard deviation 2.9. Look for the standard deviation. Something like it's not normally distributed. Okay? It's okay, no problem. We go to the T value here. The T value here is negative 8.6. and degree of freedom is 21, and significant value is 0.006. That means there is a significant difference between without and with at that. So how hypothesis null also rejected. We reject the hypothesis no. So one sample t-test we found that significant. PET sample t-test also significant. So both of these tests we also reject the hypothesis null. Okay. Okay. This is the how you run the PET sample. And now we go the last for the t-test. Okay. T-test is about t-test independent is about you want to compare different two group. For example, here maybe you want to compare between male and female. Maybe, maybe I don't know. It depends to you. Yes. So group one, group two, you want to compare mean score for the group one and group two. So one you accepted, you already state your hypothesis null, and then we run the analysis and what your decision making and what is your conclusion. Okay. If a significant, reject HO. If not significant, fail to reject HO. Okay. So this is example here. A study was done to compare job stress between two employee groups. Data were solicited from the randomly selected sample. Test for the difference at 0.05 level of significance. Test the hypothesis null on the difference at 0.05. So this is data. Okay. We need new data. Can you insert the data in your SPSS? How you insert this data in your SPSS and run as well? I give you 2 minutes. Before we run the analysis. We have only two variable here. Okay, what is the variable? Variable number one is a job stress. Variable number two is two groups. Okay, we have two variable here. We call the job stress. The another one is a group. So first we go to the variable. First you click the group. Second is a stress. So we do need the decimal. Value, yes, we need this value. One is referred to GP1. Two, we refer to the GP2. So group one, how many is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we need 1 here. So the value of the stress 25, 23, 23, 24, 20, 19, 24, 22, 27, 21. And the group 2, 19, 24, 26, 25, 18, 21, 20, 21, 24, and 23. So we have the variable group and stress. And run for the analysis. Okay. So how to run the analysis? First, go to analyze, complement, independent sample to test. Okay, independent sample to test. So what you want to test? This one, trace. So which one do you want to compare this group? So bring the group to the grouping variable and there is a question mark is there. You need to define the group. If not, you cannot click the OK here. So define the group. Group 1 is 1, group 2 is 2. Continue and OK. So here, from this output, we found that group 1 is 10, group 2 is 10. Is the mean score here between two groups and the standard deviation. And go to the Levin test. Okay, Levin test is about the homogeneities. Yeah, I mentioned this early on the morning. Said the homogeneities is about the how the variance is similar among the group. So we found here is a not significant. It's not significant. That means your group or group of the each group is a similar variance among them. If significant, okay, if significant, for example, you got the 0.02 is significant. That means you have two choice. Okay, you have two choice. Either you run this analysis or you run to the non-parametric test. But sometimes the student is they choose this test because it's more easy to understand compared from the non-parametric test. So if you have the significant value is a significant, that means you need to read from below this one. Equal variance is not assumed. Okay, it's not significant here. This is not significant. It's okay. You just read from here, from the upper one. But if equal variance is not assumed, you need to read from below this one. But actually, the finding is the same actually. Okay, it's the same. So what our conclusion here? Conclusion which we found it here 0.5 here is a not significant. That means you fail to reject the hypothesis null. Before this, you accept the hypothesis null. Okay? But this is a fail to reject hypothesis null. Okay. Go back to our PowerPoint here. Okay. It's already there. It's already there. I say the output here. Look for this one for the homogeneity test. Okay. It's equal between the group, and we have found that the p-value for the t test between two groups is not significant. So this is the result. Because of the t-value is not significant, that means H or fail to reject, and no significance between stress and job location. Okay, that's the result. Okay, the second one is about ANOVA. This is also popular among the student. Okay, ANOVA actually is extension from the t-test only 2 groups, but ANOVA is more than 2 groups. So you want to compare 3 groups. One. If your data is not normally distributed, you are using the Kruskal-Wallis test. But if your data is already normally, you just only run the ANOVA. Okay. So ANOVA stands for the analysis of variance to test more than 3 population is equal or not. And also that your dependent variable also must be interval or ratio measurement scale. So for ANOVA here, we using the F test, F value. But for the t-test, we're using the t value. Okay? We have the t value. So we're using this one is F test. So hypothesis null here equal to mu1 equal mu2 equal until how many you want. But normally it's 3 groups. Okay? So type of ANOVA. Okay. There is at least 7 types of the ANOVA, but the most popular is one-way and two-way ANOVA. Okay? One-way and two-way ANOVA. So this workshop we will run to one-way and two-way ANOVA. Okay? The other rest is maybe in what we call in non-parametric tests, including the Kruskal-Wallis test. Okay? So one-way ANOVA or analysis of variance used to claim that 3 or more population mean is equal. This extension to the independent sample t-test. But in the one ANOVA, the response variable is dependent variable, and factor variable is an independent variable. So maybe you will confuse between response and factor. So response is here is referred to dependent, and factor is referred to the categorical variable. So what is our assumption is same with the t-test. Your sample is random. You have the variance is equal among the group, and should be the data is normally distributed. So I have the example here. Okay. Economists wish to compare household expenditure on electricity and gas from the 4 major cities and surrounding. C is referred to the economists. Obtain the random sample, remember random, from the 25% household from the each city, which one is the city? Adelaide, Hobart, Melbourne, and Perth, and ask them to keep record of their energy expenditure over a 6-month period. After 6-month period, the researcher will compare about the expenditure for the electricity and gas. So she want to test any difference between them based on the alpha value 0.05. Okay. Can you open data one-way ANOVA? Where is the one-way ANOVA? So this is one-way ANOVA. So any difference between them? Or you go to analyze, click also under complements and go to one-way ANOVA. So what is the factor? Factor is city, and the dependent is a cost and electricity. Look for the post hoc. The post hoc only one equal variance ratio. Normally we take here 2 key, not R2 key, 2 key. Continue. Contrast, it's okay, no problem. Option, Okay, option you need to check descriptive homogeneity of parents. Continue and okay. So this is the result. We have the mean score here. The Levin test also is not significant. That means four of the group is equal variance. From the ANOVA, F test we found it is significant. So which one the group is different among them? We go to the post hoc test. Okay? We call the multiple comparison. So we found that here. Look for the significant label here. Only two group. Okay? Only two group between elderly and pets. The rest is okay. There is no difference. We suggest we have the difference among the major cities in terms of the expenditure on electricity and gas. Okay? Here, we already mentioned that. Only this one. So this is the write-up. One significant difference as well. Okay? You just write up something this one. Okay. Two-way ANOVA. I think I skip this one, two-way ANOVA. We go to the correlation. Okay. Correlation also popular among the students compared to two-way ANOVA. Okay. So correlation, we have the three type of correlation. Pearson, the most popular is Pearson because this is a parametric test. Compare Spearman rank and Kandel rank is a non-parametric test. Okay. For the non-parametric test, we go to the Pearson correlation. Huh? So the concept of the correlation is about the relationship between two variables. Okay. So we call the positive relationship when the R is referred to correlation is more than when at n positive, not negative. It's positive. But sometimes it's negative. It depends to your data. Okay. So R is referred to coefficient correlation. Okay. So what is assumption for the correlation is first is about linear relationship between two variables and maybe it's cause and effect between independent and dependent variable. Okay. For example, when A is increased, B also increase or decrease. So that is cause and effects. Spearman rank correlation is more if your data is ordinal. One variable is ordinal, the other variable is interval. So we need a Spearman rank correlation. Kandel rank is about if your data is you using the ordinal data. What of data is ordinal. So we run the Kandel rank correlation. So how you interpret the rank correlation? The rank correlation between 1 to 1, negative 1 to 1. But sometimes the researcher using these guidelines, but it's popular if you are using these guidelines based on the Salkin 2007. Okay, the 2007. So this is a graphic. Okay, example. Okay. The anxiety and depression. Any relationship between two. This relationship. Okay, we have the data here. You go back to the example, but we want to find out this one. Okay, this is the data. So we have the score is 0.60. Okay, and not significant. Okay, it's not significant. Okay, positive and not significant. Okay, data here, you run. Okay. The anxiety and expression, we have the value is 0.6. It's okay, it's medium correlation, but it's not significant. Why? Maybe of the number of the sample is very small. At least, actually, for the correlation, at least is 30 sample to show your correlation. Okay. Okay, I give you an example for our job survey here. Analyze, go to correlate, bivariate, autonomy, and routine. So they have three here: Pearson, Kendall, and Spearman. So we have the Pearson, Kendall, and Spearman. We look for the Pearson and click OK. Here's the result. So this is the result. Okay, the correlation is very low and not significant. Not significant, even though the sample is more than 70. Okay, okay, how you write this one? Okay, that's all. Thank you.